Good day, everyone. Now, senior, let's continue to theorem 3 in circle geometry. This is a theorem of angles in the same segment. The theorem states that the angles in the same segment are what? Equal. The angles in the same segment are equal. This is what we mean by angles in the same segment. Look at this segment here. Look at this segment here. Can you see what I'm saying? That segment, this chord divides the circle into two segments, the minor one here and the major one here. Now, you will easily see that these two angles, AYB and AXB, are both in the what? Major segment. Those two angles are both in the major segment. So, those two angles are in the major segment. So, consider angle AOB. If you consider angle AOB is formed on this sector or is formed on this arc at the center of the circle. Look at this arc. This arc is forming angle AOB at the center of the circle. So, let me try and root that gently. This arc forms angle AOB at the center, and it also forms angle AXB on the circumference and AYB on the circumference. Meaning that from our earlier theorem, this angle is equal to 2AXB. Angle at center is twice angle at circumference. This angle AOB is also equal to 2AYB. Can you see that? Angle AOB is equal to 2 times angle AXB. Also, angle AOB is equal to 2 times angle AYB. So, what that means is that, for the same reason, AOB is at the center, AXB and AYB are at points on the circumference. So what that means is that AOB is equal to AOB. I can write this. AOB is equal to what? AOB. And firstly, we said AOB is 2 times AXB. And AOB is also 2 times AYB. That means that 2 will divide 2, and what? AXB will be equal to AYB. So that's the proof we want to write, that these two angles are the same. These two angles are the same, and we have done that. All right, let's now go to the examples. The first question says we should find angles A, B, and C. Now, if you look at this diagram very well, this arc, look at this arc. This arc forms C on the right here and forms 32 here. So C and 32 are angles in the same segment. Look at my hand again. C is formed here. 32 is also formed here. So C and 32 will be the same. They are both formed on the same arc, and they are both angles in the same segment. So you write C is equal to 32 and put the reason in bracket, same segment. Also, if you look at the diagram where A is formed like this on this arc, let me draw that again. A is formed like this. Excuse me for the way that looks. A is formed like this on this arc. Can you see that? Then also on this arc, 42 is formed. So that means A and 40 are the same. They are both formed in the same segment. You understand? This arc forms 40 here and A here. So that means A is equal to 40. The reason is that the two angles are in the same segment. A is equal to 40. Same reason, same segment. B is also equal to 40. Is that right? Let's check. Yeah, B is also equal to 40. 40, 40, 40. Each of them is formed in the same segment on this same arc. So B will also be equal to angle B is also equal to 40 degrees. Let's continue. The next question in number 2 says we should find angles E and D. First of all, there's a theorem we must also write called Theorem 4. Angle on semicircle. Theorem 4 is titled angle on what? Angle on a semicircle. Let's look at this theorem before we go answer number 2. Now, the angle on a semicircle is equal to 90 degrees. This is very easy to prove. Let's say we have a diameter AOC like this. AOC forms 180 degrees here, and it also forms angle ABC here. Now, you will notice that this 180 is equal to 2 times ABC, because 180 is formed on this. 180 is formed on this diameter at the center. Let me try and redraw everything from the beginning. 180 is formed on this diameter at the center, and on that same diameter, ABC is also formed. Can you see my diagram? Angle 180 is formed on this arc at the center here. And on this same arc, angle what? Angle ABC is also formed. So that means using angle at center is equal to twice angle at circumference. We will know that 180 is equal to 2 times ABC. So using that concept, angle at center is twice angle at the circumference. We can say that AOC, the obtuse angle AOC here, is equal to 2 times angle ABC here. So that gives us what? That gives us what? 180 is equal to 2 times ABC. So that means ABC will be 180 over 2, 90 degrees. That's our proof. Let's now go back and answer question 2. Question 2 says we should find angles E and D. E is very straightforward. With the theorem we just wrote, E will be equal to 90 degrees because it is formed on a semicircle. This is a semicircle. This is a semicircle. E is an angle on a semicircle. This is a semicircle. Can you see this diagram? This is a semicircle. So E is formed on that semicircle. That means angle E is 90 degrees. We write our reason down after writing the answer. Angle on a semicircle is equal to 90 degrees. So after getting E as 90, I think I did not include that answer. E is equal to 90 degrees. E is equal to 90 degrees. What's the reason? Angle on a semicircle. E is an angle on a semicircle. So after getting E as 90 degrees, let me write that here. 90 degrees. We now go ahead and find D. Now, look at this arc. Look at this arc. This arc forms angle 115 here. And also forms D here. So that means D and 115 are the same because they are angles in the same segment. So we say D is equal to 115. Okay, I think I wrote a wrong reason here. D is equal to 115. The reason would be that they are both angles in the same segment. Not angle at center is twice angle at circumference. The reason is they are both angles in the same segment. This is 115 here. This is 115. And this is what? D here. Both are formed on the same segment. They both are formed inside the same segment on this arc, but inside the same segment here. So angles in the same segment are what? Are equal. So D is equal to 115. Let's go to question 3. In question 3, we have to find F, G, and H. This is a simple question. F is straightforward to find because F is formed on a semicircle. This is a diameter. This is a diameter. So that means this is a semicircle. F is sitting on that semicircle. That means F is equal to 90 degrees. Angle on a semicircle. Now consider the triangle containing this 90, this 56, and what? And G. Those three angles are in a triangle. So 90 plus 56 plus G is 180 degrees. The reason is that they are angles in a what? In a triangle. The reason is that they are angles in a triangle. The reason is that the three angles are present in a triangle. And sum of angles in a triangle is equal to 180 degrees. So that means 90 plus 56. 90 plus 56, which is 146, plus G is 180. And G will be 180 minus 146, 34. I hope you can see that. That's how we got our G as 34. Is that clear? Now, let's continue. We have to find H. Now, there's something about quadrilaterals. Once this is 90 degrees, and this is also 90 degrees, you understand? Once the two parallel sides are 90 degrees, so once the two opposite angles are 90, these two are also 90. So that happens in a quadrilateral. It means that these two sides must also be parallel. They must be parallel so that they can be perpendicular to the adjacent sides. So that means this angle 2 is 90. So H plus G is what? 90 degrees. Let's quickly do that. H plus G, I'm going to separate it here. H plus G, hold on. H plus G is 90 degrees. We already know G as 34. So H plus 34 is 90. H is equal to 90 minus 34. H is equal to 56 degrees. H is equal to 56 degrees. That ends question. That ends what? That ends question 3. Let's go to question 4. I'm coming. I think I've lost the page. Okay. Okay. Hold on a second. Okay, this is where I'm supposed to be. Okay, let's go back to the exercise. That was question 3. Let's now go to question 4. IJ65, okay? Okay. Let me be sure I'm not leaving too much space, okay? Question 4 now. There's a circle here. There's a circle here. Okay, this is a diameter. Okay, this comes this way. Let me check the diagram I want to. Okay. Okay, IJ65. All right. So the center of the circle is marked here. We have to find I and J. This is a very simple question. Let's just go straight to it. One thing we know here now is that with the way the diagram is drawn, I'll be showing my lines. If this is 65, it means I is also 65. Can you see my line? The reason is that they are both formed on this arc and formed in the same segment. This is the segment in which they are both formed, in the major segment. So we have our answer for I. I is equal to 65 degrees. The reason, same segment. Same segment. Now, after getting I at 65 degrees, you need to check this one. You need to check this one. If you know this place at 65 degrees, I plus J should be equal to 90, because this is an angle on a semicircle. Can you see? Since this is a diameter, it means this must be what? 90 degrees. This whole angle here must be 90 degrees. So that means I plus J is equal to 90 degrees. The reason is simple. Angle on a semicircle. The two angles are present on a semicircle. So if we put them together, they'll be 90. So 65, I already know I. 65 plus J is 90 degrees. So J is equal to 90 degrees minus 65. J is what? 25 degrees. J is equal to 25 degrees. That ends question 4. Let's go to question 5. Excuse me. Let's go to question 5. What's in question 5? Okay, K53, yeah. Okay. Let me scroll this up a bit more. I'm trying to make my diagram big so you can see it well. Okay, that's not going to allow me to write it once. Excuse me. Okay, let me check it again. K53 L O. Okay. Center of the circle 90. Okay. L K 53 L O. We have to find L and K. Now, if this place is 90, look at this one. If this is 90, the remaining portion too will be what? 90. So that already marked. I know that 53 plus K should be 90 degrees because the two angles are sitting on a what? On a semicircle. The two angles are sitting on a semicircle. This is a semicircle. This is a diameter and this is a semicircle. So that means this angle is on a semicircle. This angle is on a what? Semicircle. So it must be equal to 90. Let me mark it with this. So that's 90 degrees. 53 plus K is equal to 90 degrees. So what do we get? K is equal to 90 minus 53. K is equal to what? 37 degrees. Now, after getting L, this is another 90. So if this is 37, 37 plus 90 plus L, these three angles put together must give me 180. So I'll say 37 plus 90 plus L should give me 180 degrees. Angles, what's the reason for that? Angles in a what? Triangle. Angles in a triangle. So that tells me 127 plus L is 180 degrees. L is what? 180 minus 127. If L is 180 minus 127, it means L is what? 53 degrees. So I think that answers question 5. Let's go to question 6. Question 6, NM20P. Okay, let me see if I can memorize that. Okay, number 6. I'm trying to make the diagram very big so you can see it well. Okay. Let me check. Okay, there's a diameter there. NM20. What else do I have? P. Okay. Now, let's take it one by one. Now, this diagram shows that this triangle in purple is isosceles. So that means if this place is 20, let me clean it and rewrite. That means if this place is 20, M2 will be 20. So I can go ahead and write that straight. M is 20. The two angles are base angles of an isosceles triangle. This triangle is isosceles. So the two base angles, these are the two base angles. The two base angles will be what? Equal 20, 20. So let's just put 20 here straight for M and circle it. Circling it means I'm trying to tell anybody marking my script that I actually provided that. It was not in the question. So let's continue. What does this tell us? Look at my hand now. I'm going to change this to red. If this is 20, if this is what? If this is 20, this will also be what? 20. So these two angles are in the same segment. You understand? 20. Can you see what I'm showing you? See now. If this is 20 like this, if this is 20, this will also be what? 20. So 20 here, 20 here too. Because both of them are formed on this arc and they are in the same segment. They are both formed on this arc like this, 20, 20. So they're in the same segment. That means we know another part of our shape, 20. I'll circle it because I provided it. Now, n plus m must give me 90. This is a semicircle. Look at my yellow. This is a diameter. That makes this a semicircle. An angle on a semicircle is 90. So this must be equal to what? 90. Can you see my yellow lines well? See now. This must be equal to 90 degrees. It means the whole angle here is what? 90. So n plus m is equal to 90. What's the reason for that? N plus m is what? 90. The reason is that it's an angle on a semicircle. It's an angle on a semicircle. We already know the value of m. What's the value of m? 20. We already know the value of m to be what? 20. So n plus 20 is 90, and n is 90 minus 20. N is 70 degrees. Can you see that? N is what? 70 degrees. So I know another angle in my shape. I can go ahead and put that 70 degrees. Can you see that? N is 70. So I'm trying to get P. P2 is 20. I'm going to show you now. P is 20 also. Look at my red line. Look at my red line. This is 20 here on this arc. This is 20. So this will also be what? 20. This will also be 20. They're in the same segment. Let me start all over again. So, or let me use yellow. 20. If this is 20, this will also be what? 20. They are in the same segment and formed on the same arc. So just look at that source. They are sitting on the same arc. One is formed this way. The other is formed this way. So both angles are equal. 20. Both angles are what? Equal. 20, 20. They are formed the same way. I'll try and draw red on the yellow. 20, 20. So that you can see it well. They are both formed on this arc and in the same segment. So P is also what? 20. For that reason, P is what? 20 degrees. Let's take it one by one. Let's take it one by one. P is 20 degrees. What's my reason for that? Same segment. Same segment. P is 20 degrees, same segment. So I can put that here. 20 degrees, same segment. All right. So that ends question 6. Let's go to question 7. Let's go to question 7. Let me change it to orange. That's a cool color too. Question 7. Wow. Okay, let's just say I have a circle like this. Okay, let me try and give enough space for my circle. Let's just say I have a circle like this, and I have one big chord here and another small chord here. So I now have lines. Then I have lines here. Lines here. You understand? Another one here. Another one here. I think that's what our shape entails. Okay, at the point of intersection here, I have one tiny little angle, Q. Then SVUR, SVUR. What else? 40, 60, 10. Okay. 40, 60. No. Count well. Okay. T 40, 60, 10. So this place is T 40, 60. I'm going to try and write that one. 10. 40, 60, 10. So here, this is pretty simple. T is equal to 10. I think I can mark that out. If this is 10, T will also be equal to what? 10. Can you see my hand? T is also 10. They are formed on the same arc, and both of them are in the same major segment. 10, 10. They are standing on the same arc here. 10, 10. Standing on the same arc. So T is equal to 10. Same segment. Let's write that straight. T, okay, that's not clear at all. T is equal to 10 degrees. Reason, same segment. Same segment. So I can put 10 degrees here, now that I know T. Also, I can, okay, V is also 40 in the same way. In the same way, V is also 40. Look at my hand. V is here, 40 is here. Both of them are formed on this arc, and they are both in the same segment. So in the same way, V is 40. Same segment. V is 40, same segment. Let me put it straight. 40. Let's get U. U is also 60. Look at my diagram here. Just look at my lines here. This angle, 60, is formed the same way this U is formed. 60 is formed the same way U is formed. U is formed like this. 62 is formed like this on the same arc. So if this place is U, this place is also the same as U. So same segment. Or can I use yellow again so that you can see it well? 60, 60 on the same arc. So U is also what? 60. U is equal to 60 degrees. Same segment. U is equal to 60 degrees. Same what? Segment. U is 60 degrees, same segment. So I can put 60 here straight away. Circle it. So you can show that I provided those angles. What else do we need? S and R. Let's get Q first. Look at this triangle. This is a triangle. You understand? 40, 60, and Q are present in a triangle. 40, 60, and Q are three angles of a triangle. So that means that what? That means that 40 plus 60 plus Q is what? 180 degrees. The reason is that they are angles in a triangle. There are angles in a triangle. So 100 plus Q is 180 degrees. Q is equal to 180 degrees minus 100. So Q is 80 degrees. Q is equal to 80 degrees. So I know this. I can put it there if I like. Let me just 80 degrees. I think I'm beginning to like this purple also. Okay, if Q is 80, this place too is 80. If Q is 80, vertically opposite angles are equal. This place too is 80. If this place is 80, if this place is 80, the remaining part of that straight line will be what? 100. So this place will be what? 100. Let me write it well. This place will be what? 100. So I can use 100, 10, and S to find the value of S. Can you see? Because the three are present on the same line. Sorry, present in the same triangle. These are three angles of a triangle. S, 100, and 10. So I can use that triangle to get S. Let's go ahead and do that. How do I do that? I'll say also S plus 10 plus 100 is equal to 180 degrees. The reason angles in what? Excuse me, I want to make it as neat as possible. Angles in a what? Triangle. Angles in a triangle. So S plus 110, X plus 110, S plus 110 is 180. Angle S is 180 degrees minus 110 degrees. So angle S is what? 70 degrees. Angle S is 70 degrees. So after knowing S, I need R. S and R are the same segment. Look at my pink line. This is R here. On this arc, S is formed the same way on that same arc. Both are in the same segment. So if S is 70, R is also equal to what? 70. S is equal to R is equal to 70 degrees. So that ends question 7. Let's go ahead and do question 8. What's in question 8? I think this will be easy. 126xy. Okay. Question 8. Let's give enough space for the circle. Okay, that's our diagram. Okay, x, w, y, z. Okay, I think I made a mistake. This angle here is w. This is the center of the circle. So x, w, y, what? Z. The question says, okay, we are just to find the lettered angles. So pretty straightforward. Our answer starts from here. 126 is 2w. Sorry, w is 2 times 126 because w is formed at the center by this, you understand? By this arc. W is formed at the center here. But that same arc, okay, sorry, I cleaned something I was not meant to clean. That same arc, look at my hand, that same arc this same arc forms 126 on the circumference. So the angle it forms at the center, W, will be equal to 2 times 126. Can you see that? So we are going to say W is equal to 2 times 126. How do we do that? W is 2 times 126 degrees. Angle at what? Angle at center is twice angle at a point on the circumference. So W is 252 degrees. Now, when we know W as 252, we can easily get our X, because X and W are angles at a point, which is the center of the circle. So after knowing this one as 252, after knowing this as 252 degrees, we can easily get our X. How are we going to do that? X plus W is 360. What's that? Sum of angles at a point. The reason is that the sum of angles at a point is 360. So X plus 252 is 360. X is equal to 360 minus 252. X is equal to 360 minus 252. That's 8. 5 minus 5, 0. 3 minus 6, 1. X is equal to 108 degrees. X is equal to 108 degrees. Take note of that. What else are we to find now? What other angle do we want now? We know this now, 108. Let me circle these angles we are looking for by ourselves. Okay, the same way, 108 is equal to 2 times y. This 108 here will be equal to 2 times y. The angle here is 2y. Angle at center is twice angle at any point on the circumference. Can you see the way I drew those lines? Can you see? This arc has formed 108 at the center of the circle, but it has also formed y at a point on the circumference. But the angle formed at the center, which is 108, will be twice this one formed at the circumference, which is y. So that tells us what? That 108 is equal to, that tells us 2y is equal to 108. Or 108 is equal to 2y. Anyhow you write it, it's okay. So the reason is angle at center is equal to 2 times angle at a point on the what? Is equal to 2 times angle at a point on the what? Circumference. So that tells us that y is 108 degrees divided by 2. So y is 54 degrees. Y is 54 degrees. If we know y, we easily know z. If you know this place as 54, then this is a straight line. This line is a straight line. So on a straight line, 54 plus z is 180. Can you see that? 54 plus z is what? 180. So we can say 54 plus z is 180 degrees. What's our reason for that, senior? Straight line. The two angles are on a straight line. So z is 180 degrees minus 54. Z is equal to 126 degrees. So that ends question 8. I'm going to give an exercise on this. Or should I just do it straight? Okay, let me just do it straight. Classwork, let's do it straight. Classwork. Find the lettered angles. Find the find the lettered angles in the following diagrams. Find the lettered angles in the following diagrams. Okay. Number one, let me draw something like the previous circle for you. Okay. Find the lettered angles in the following diagrams. Okay, 130 degrees. Let's say this is center of the circle. This is K. This is U. Let's make this come here too. Okay, this is Z, and this is Y. Or let me change those letters so you don't get confused. This is B. This is A. Let's use another marker. Okay. So you find those lettered angles in that diagram. Number two, I'm going to just make them look exactly like what we were given. Okay. Number two. Okay. 120. Let's say this is 120. This is T and this is R. So find T and R if that's 120. Number three. Just going to make them similar to what we were given. Okay. This is D. Okay. Let's say this is 128 degrees. We are finding, let's say, G and D. We are looking for G and D in question 3. Question 4 now. I'm going to be a bit more faster. Question 4 now. Okay, 15. This is 15. Okay, let's say this is 15 and this is 40. Or let's make this 40. This 50. Okay. Okay, let's say this is 38. This is now L. This is U. Okay, let me give an answer for these two. 47. Are you getting what I'm saying? So that will help. We now need L, M, N, P, and Q. So that will be enough for question 4. Let's go to question 5. Let me make it more interesting and give you something like that looks exactly like question 5 here. Okay, so we have a circle like this, diameter, triangle, Okay. 49. Okay. U, T, W. So find those angles there in number 5. Number 6, I'm just copying and changing values. There's nothing special about what I'm doing here. So number 6 now. Number 6 now. I think this is what I like to put in number 6. Okay, T, K. Okay, let me put 18 degrees here. Let's make this place 18 degrees. Let's make these two equal. Okay, I'm going to use another color for that later. I want H, and okay, let me do it this way. Center O. Center O. 18. Let's say these two are the same. So, you know what to do now. Comedy, you still need more information? Okay, no. Okay, find Q, find R. Find Q and R there. If this is the center, find Q and R. Let's try and add more. Oh my God, I'll have a lot to mark, but no problem, no problem. Okay. Let's just make this look like this. Center O. Okay. I think I need to make that a bit close. Let me see. Okay. U, V. Okay. Let's make this 58 degrees. So you find U and V. You find U and V. Let's just add one more. Just one more to make it 8. Just one more. Or should I say that's all right? Let's add just one more. Let's add just one more. Okay. Oh my God, this is always... Okay, I think I got it there. Now, we want to find C, we want to find D and E. Let's assume this is 61 degrees. So you find C, D, and E, and these two are parallel. So that's the exercise for the theorem. That's a classwork for the theorem. We now go to theorem. We go to the next theorem in the next video.